you determine empirical formulas and molecular formulas. So to start things off, let's define what an empirical formula actually is. And it's the formula with the simplest whole number ratio of atoms present in a compound. So you'll understand what that means in a couple minutes. So there are 4 steps we need to take to find empirical formulas. The first thing we need to do is convert the mass of each element to moles using this conversion factor. Then we're going to divide each molar quantity by the smallest number of moles. Round to the nearest whole number. If you can't round, like you have 1.5, 2.5, you need to multiply each mole ratio by the smallest whole number. That will convert all values to whole numbers. Okay, so in these examples, we may see that. So let's start. Well, before we start, go ahead and take a minute to pause this video and write your notes down. And go ahead and write down the example as well. So example 1, a sample contains 5.723 grams of silver, 0.852 grams of sulfur, and 1.695 grams of oxygen. And we need to figure out what the empirical formula is. So go ahead and pause this video and take down these notes. So we're back. You've paused the video, you've taken down the notes. So let's go ahead and determine this empirical formula for our first example. So I'm just going to adjust this a little bit. So again, the example is a sample contains 5.723 grams of silver, 0.852 grams of sulfur, and 1.695 grams of oxygen. What's the empirical formula? So the first thing I'm going to do is list out my elements. Okay, now I'm going to write down the mass given. So this is kind of like our given and find. So once I have the masses given written down, I'm going to use this conversion factor to convert my grams into moles. So dot in a line. And you're going to need your periodic table from this point on. So I have my periodic table right here, ready to go. So we have grams of silver on the top, so we want it on the bottom so it cancels out. So it's going to be grams of silver underneath 1 mole of silver. And looking at my periodic table, I see that, hey, silver's atomic mass is 1.07. No, it's not. That is not the number. It's 107.87. So I'm going to write that down. And we're just going to do the same thing for sulfur and oxygen. So now we're at this point. We have our conversions set up. So let's go ahead and calculate. So we're going to take 5.723 divided by 107.87, and that should get us 0.053054 moles of silver. And I would urge you to carry as many decimals as you can, because sometimes the numbers are super close and it makes it kind of difficult to decide which one's the smallest. So for sulfur, you should get 0.026566 moles of sulfur. And for oxygen, 1.695 divided by 16 gets you 0.10593 moles of oxygen. So that's step 1. So now step 2 is to examine these 3 mole values and divide each of them by the smallest. So looking here, my 0.1, that's the largest, and it's between 0.05 and 0.02. So this 0.026566 is the smallest, so we're going to go ahead and divide each number by this. So to show that, yes, you have to write it out. I'm so sorry. And then something divided by itself is 1, so we like that. That's easy math. So this is how you would show your work for this step, step 2. And let's go ahead and calculate this again. So for silver, we're going to get 1.99. This is 1, and for oxygen, we will get 3.98. So round to the nearest whole number is the third step. So 1.99 rounded becomes 2. 1 is already a whole number, and 3.98 rounded becomes 4. So these are all whole numbers. And now these whole numbers here are going to be our coefficients. Okay, so whichever number belongs to the element, that's what you're going to write as the subscript. So for silver, we're going to write 2 as a subscript. For sulfur, sulfur has only 1, so we don't need a subscript there because it's 1. In oxygen, you're going to put a 4. And that is our empirical formula. Okay, so let's try another example. Here we go. Go ahead and take a moment to write this down. So go ahead and pause your video here, take a minute to write this down, and then we can get started. So a compound is made up of X and Y. In the compound, there is 43.78% X and 56.22% Y. The molar mass of X is 84.01 grams per mole, and the molar mass of Y is 120.12 grams per mole. What is the empirical formula, and what is the molecular formula? Okay, so this one's a little different. Notice my little disclaimer here. If you're given percentages, you need to assume you have 100 grams. Why? Because if you're given percentages, it adds up to 100. So it makes your math super easy. Let me show you. So the first thing I'm going to do, there we are. I'm going to list out my elements. In this problem, I'm working with X and Y. Okay, so for my X, we have 43.78%, and Y we have 56.22%. So we have percentages, so I'm going to assume we have 100 grams, which means I have 43.78 grams of X, and I also have 56.22 grams of Y. Okay, so first things first, we need to convert our grams into moles. So dot and a line, dot and a line. So grams of X is going to go on the bottom because we want that to cancel out, and it's going to be mole of X on top. Same thing for our Y. And we're going to use the information from the prompt. So X has a molar mass or atomic mass of 84.01. And Y has a molar mass or atomic mass of 120.12. So this is how we're going to set it up, and we're ready to do some division. So we're going to take 43.78 0.78 divided by 84.01. And we're going to get 0.521128 moles of X. When we do the same for Y, we're going to get 0.46803 moles of Y. So comparing these two numbers, this one is smaller. So we're going to divide both numbers by our 0.46803. Anything divided by itself is 1, and the 0.521128 divided by the 0.46803 is 1.11. Okay, so now step 3, we need to round to the nearest whole number. So 1 is already a whole number. 1.11 rounded to the nearest whole number is also 1. So here our empirical formula is going to be X with a subscript of 1 and Y with a subscript of 1. So it's just going to be XY. Okay, guys, so now that we have figured out the empirical formula, we need to figure out the molecular formula. So I've added this information. So it's known that the molar mass of XY is 408.26 grams per mole. So how we find the molecular formula from the empirical formula is this. Let me turn this. So step 1 is to calculate the molar mass of the empirical formula, which is EF. Okay. And then the second step is to divide the empirical formula molar mass by compound molar mass. Okay, so let's do this in this space right here. So X has an atomic mass of 84.01 grams per mole, and Y has an atomic mass of 120.12 grams per mole. So I'm going to add this together so I can figure out the molar mass of my empirical formula right here. So 84.01 plus 120.12 gets me 204.13 grams per mole. So I'm now going to take my guys, I lied to you. This is the opposite, but it's okay. So you're going to divide the compound molar mass by the empirical formula molar mass. I'll make a note of this on the video, don't worry. So I'm going to take my 408.26 and divide it by my 204.13, and that gets me 2. So now I'm going to take this 2 and multiply it by my current subscripts on my empirical formula to get my molecular formula. So my true molecular formula is X2, Y2.